Okay guys, I uploaded that first video and realized I wasn't quite finished with showing you guys how to reduce fractions. As you guys may be aware, not all fractions look like some of those fractions we practiced reducing just a few minutes ago. Sometimes we have fractions that, to show you first, we have fractions that, like in that 10 over 12 we just looked at, this is what's called a proper fraction. It's called a proper fraction because the number on top is smaller than the number on the bottom. So in other words, your numerator is smaller than your denominator. And like I said, we refer to that as a proper fraction. And we reduce, as we saw with the previous video, we reduce our proper fractions by dividing both the top and the bottom by the same thing. Let me switch this marker up real quick. By dividing the top and the bottom by the exact same thing. So in that 10 over 12, we saw that in the previous video, we could divide both of those by 2, and therefore that reduced down to 5 over 6. Also a proper fraction because the smaller number is on top. That one's just your reduced proper fraction. Another type of proper fraction is what's called a mixed fraction, or sometimes just referred to as a mixed number. In comparison to, the 10 over 12 that we just saw a second ago, if I had a number in front of that fraction, so like a whole number. For instance, let's say I had the fraction 5 and 4/8. So here you guys can see that I have a whole number written in front of this small fraction 4/8. I'm going to go ahead and categorize this as a proper fraction too, just because we're going to reduce it the exact same way as we did our proper fractions just a second ago. What happens is, what we're looking at here when I'm referring to, say, our pizza examples, for instance, what this situation shows us is that we actually have 5 whole pizzas, and then the last pizza has been cut into 8 slices, but it looks like someone has eaten 4 of them. So if I'm cleaning up after a pizza party and I have 5 whole pizzas left and then 4/8 of another, this is what I'm looking at. That's what I mean by 5 and 4/8. Now, we know from looking at that last video that 4/8 can be reduced, as 4 and 8 both can be divided by 4 or by 2, and we can reduce this down a little bit further to 1/2. So what actually happens here is we can see in those pizzas that actually 4/8, we can see there is our 1/2. So again, as if we're using the example that I'm cleaning up after a pizza party, I can count here that I have 1, 2, 3, 4, 5 pizzas left over, and then half of another one, and that's what we're looking at. So what happens, and why I chose to categorize that as a proper fraction, is because all we're going to do, let me get all that mumbo jumbo off the screen here, all we're going to do is keep the whole number the same. So if we're reducing this, the 5 is going to stay the same, and then 4/8 just is the only part that needs to be simplified or to be reduced, and we know that reduces down to 1/2. So actually 5 and 4/8 is reduced to 5 and 1/2. In any other example, if I have the fraction, I don't know, let's say 18 and, let's say, how about 10/24ths, let's say. I know that 10 and 24, I can divide that a little bit further just because right off the top of my head I'm thinking, you know what, they're both even, so I can divide them both by 2. Let's start there. 18 is going to stay the same, and then I'll reduce just the fraction part of it. I'm going to reduce those both by 2. 10 divided by 2 is 5, and then we know down here at the bottom 24 divided by 2 is 12, and actually 5/12 cannot be reduced any further, so this reduces down to 18 and 5/12. Or if I had the fraction, I don't know, let's say 3 and how about, I'm trying to think of a different one, let's say 12/48. Looking at just that fraction, I know there's a couple options here. I can see that both 12 and 48 are both multiples of 2, so I very well could start there. or perhaps I noticed that they're both multiples of 12. Either way, let's say we did just start with 2. Once again, the 3 just stays the same, and we can reduce just the fractions. So 12 divided by 2 we know gives us 6, and then down at the bottom 48 divided by 2 we know gives us 24. So once again we see we can go a little bit further, and you may see here that both 6 and 24, you may have noticed that they're both multiples of 6 or 2 or 3, and we know that when we reduce this down, once we get down to the very end, that's going to give us the fraction 3 1/4. Once again, when you have these mixed numbers, they simply just reduce the same way as the proper fractions do. You just keep the whole number the same. The only other type of fraction that you all may run into at the end of these problems is what's called an improper fraction. As I just described to you guys, a proper fraction means that the top number is smaller than the bottom number. Well, then you guys probably know where I'm going with an improper fraction. An improper fraction simply just means that the top number is bigger this time, is bigger than the bottom number. So an improper fraction may look something like this. Let's say I have, I don't know, let's say 15, let's say eighths, because I'm going to show you guys using pizzas again. So say if we have 15 eighths, you know, I showed you guys at the very beginning that a fraction represents a part. So what the heck is 15 out of 8? And to give you guys just a visual example of what that would be in terms of our pizzas again, if I have a pizza that's cut into 8 slices, then we see here that I have, this is the same thing as 8 eighths. If I sat there and counted 1, 2, 3, 4, 5, 6, 7, 8. There's 8 slices on that pizza, so here I have 8 eighths. But we don't have 8 eighths, or that's not the fraction. The fraction says 15 eighths. So what that simply means is I have another pizza, and then that's also cut into 8 slices. And so now I can count 9, 10, 11, 12, 13, 14, 15. It looks like maybe somebody ate this last slice. And so here we are looking at the fraction 15 eighths. But once again, if we want to make a little bit more sense of this and to reduce this down to something that would be a little bit better understood, what it looks like I'm looking at is one whole pizza and then 7 eighths of another. So 1 and 7 eighths is what this is actually going to reduce down to. It makes a little bit more sense that way in terms of just collecting and saying here's what's left over. But a better way to do that without having to, draw pizzas on the board every single time, what's going to happen is we're just going to take a look at this fraction, 15 over 8, and we're going to divide it as if it says 15 divided by 8. And you guys know, that 8 will go into 15 only one time, since 8 times 1 is 8. We know that gives us a remainder of 7. And so here's what happens with that. What happens when we get that 1 with a remainder of 7, that is where our fraction is going to come from. The answer becomes the whole number of our fraction, so that would be 1. I'm going to write that down here. The remainder becomes the numerator of our fraction, and then the denominator, which was 8, which is what we were dividing by, that just stays the denominator. So that's where that 1 and 7 eighths come from. Okay, so just to try that again, that was the one we used with our pizzas. But let's try that again. Let's say we have I don't know, let's just say a different one. Let's say we have 27 fifths. Okay, so again, without having to draw pizzas and cut them into 5 slices apiece and see how many pizzas that's going to be, instead, let's just go ahead and divide that out. So we're going to take, again, top number, 27, divided by the bottom number, which is 5, and let's see what we get as our remainder. So how many times does 5 go into 27? It goes in 5 times. Because we know 5 times 5 is 25, so we write that under here, as we did that in our first day of class. We write that under there, and we see what our remainder is. 27 minus 25 gives us a remainder of 2. So writing that as a fraction would be, I'll write that out. Let's write it in a different color. How about down here? Let's write that's our 5 is our whole number. That's this one right here. Our remainder, the 2, becomes the numerator of our fraction. And then the denominator, which was 5, I'm just writing these in different colors so you guys can see where I am. The 5, which was our denominator to begin with, just stays that denominator. So my entire answer down here is 5 and 2/5. That's a completed answer down there at the bottom. One other thing I want to show you with this, also be prepared to continue reducing. And what I mean by that, what I mean by continue reducing if need be, let's say we have this fraction. Let's say we have 18/4. 18 over 4. So let's reduce that. So as we did before, we're going to take 18 divided by 4. And we know when we do so, 4 goes into 18 how many times? It goes in 4 times. Because 4 times 4 is 16, so when I subtract, that gives me a remainder of 2. So here's what I mean by, continuing to reduce if need be. When we write that out as a fraction, as we've been doing, this whole number, or my answer, I'm sorry, becomes the whole number of my fraction. My denominator is from my my numerator is from that remainder, and it becomes 2. And my denominator just stays the same. So now looking at this fraction, 4 and 2/4, you guys can probably see, based on what we did with our mixed numbers at the very beginning of this video, or at the beginning, maybe looking at the last video, 4 and 2/4 is a mixed number, and I can continue to reduce that 2/4 because remember, 2 and 4 are both even, so therefore I can divide them both by something else. I can divide them both by 2. And so when I do so, I want to make sure that I can reduce any time I possibly can. Remember when we reduce that, my whole number stays the same. My fraction, though, just the fraction part of it, 2 divided by 2 is 1, 4 divided by 2 is 2, so it just reduces again. So here, our completed answer would be 4 and 1/4. Let me give you another one similar to that. Let's say we have, let's try 29, no, not 29, let's try 20, let's try 20 over 8. Let's see, this should work, So when I'm reducing this, again, taking 20 divided by 8, we know 8 goes into 20 how many times? Only twice, since 2 times 8, and let's write that underneath here, 2 times 8 gives me 16. That gives me a remainder of 20 minus 16 is 4. So writing that out now as a fraction, when I write that completed fraction, what I have, or as a mixed number, that gives me 2 and 4/8. You guys see where maybe I might be able to reduce one more time? Just like in the last one, that just the 4 and the 8, the numerator and denominator that we have now, this is, a reduced fraction, but it's not completely reduced, since 4 and 8 I can divide again. And we've seen 4/8 many times, and we know that we can divide those both by 4. We could have divided them both by 2 and reduced again. Either way, we get down to our completed reduced answer, and that's 2.5. And if we were to look at 28ths in terms of our pizzas, if we were to do that, what I mean by that, if we had, let's say, 28ths. So here's a pizza cut into 8 slices. So this shows us 8/8 of a pizza. Here's another pizza cut into 8 slices. So there's 8/8, giving me a total of 16/8 so far. But then my last pizza that was cut into 8 slices, instead, we only have, since there's 16, then it looks like, let's see, 17, 18, 19, 20, looks like half of that pizza is missing. So here we have only 4/8 of this pizza, but giving us a total, when we've added those together, 8/8 plus 4/8 plus, 8/8 plus 8/8 plus 4/8, I'm sorry, that shows us 28ths. And as you guys can see, we have actually up here 1 full pizza, 2 full pizzas, and then a half of another. So you can see why this reduced to 2.5, if that gives you a better visual. But that's an easier, like I said, what we've been doing is an easier way to do that. So I hope that helps you guys reduce those fractions. So that's, and one other quick thing I want to show you guys with those improper fractions before we finish up with those and we jump into our addition. Also be prepared to see things like this. If I have the fraction, say, 20 over, let's say, 4. 20 over 4, not always will these improper fractions reduce to a mixed fraction. Sometimes they just reduce to a whole number. In this case, when I take 20 divided by 4, we know that 4 goes into 20 and even 5 times. Since 5 times 4 is 20, that gives us a remainder of 0. So whenever I get a remainder of 0, that simply just means that this fraction has reduced down to just a whole number. So it just reduced to 5, and that's it. There's no fraction on it. 20 over 4 is just 5 total pizzas. If we had pizzas that were cut into 4 slices and we counted 20 total slices, that actually just gives me a total of 5 pizzas. You know, also in terms of those pizzas too, remember I showed you all on the previous example that 8 over 8, that was one whole pizza, right? That we had 8 out of the 8 slices. So also know that anytime you see a fraction over itself, that simply just reduces to 1. So if I had 20 out of 20 total pizza slices, I know I ate one whole pizza. So no matter what, anything over itself is always going to be equal to 1. So be prepared to see those as well as we practice with our fractions today. And like I mentioned earlier, we are going to get a ton of practice reducing. So hopefully, you know, we'll get that down pat. So let's go ahead and let's jump into the addition then. So a way that I like to introduce addition, I'm going to draw another pizza on the board. And this might be the last time I draw a pizza on the board, I hope. You guys are probably craving pizza now. I am. So what I want to do with this pizza, I want to add up the total number of slices that, say, me and a friend are eating. And I want to add together what I ate plus what she ate, but we want to add it together as fractions. So what I mean by that, let's say that I had 2 slices of this pizza. So as a fraction, that means I had 2/8 of this pizza. And let's say my friend comes along and she also eats 2 slices. So that shows us that she had 2/8 of this pizza. So as I mentioned earlier, when we want to add these together, as you guys can see, just visually what we see of this pizza, together we had 4 out of the 8 slices. So that's what's happening when we add 2 fractions together, obviously without having to draw pizzas every single time. All we did from this fraction here, we just simply added the 2 numerators together. 2 plus 2 gave us 4. And then down at the bottom, the 8 was our denominator, and it simply just stays our denominator. Now, looking at this 4/8, you guys probably looked at that board and went, wait, she's not finished. And you're right, I'm not finished. 4/8 we know can reduce. As I mentioned earlier, we want to reduce every chance we get. We want to reduce at the end of every single problem. Looking at this pizza, we know 4/8 totals up to be about half of this pizza. We know that that's 1/2. So that's what we need to make sure we do, that we're not totally finished with this problem with just 4/8, but that's how we start. Is when you're adding 2 fractions, you begin by simply just adding the 2 numerators, and then the denominator stays the same, reduce at the end. So we know that 4/8 reduces to 1/2. So there's our completed answer. That's what I want to have on a test. I want to have that reduced answer. Okay, let's try another one without a pizza this time. Let's say I'm adding together, how about this? How about 3 over 6 plus 2 over 6? When I add these 2 fractions together, just the same way we did before, I'm simply going to add the 2 numerators. 3 plus 2 is 5. And then down at the bottom, 6 was our denominator, so 6 stays the same. Looking at 5 over 6, I cannot divide both 5 and 6 by the same thing, so that is our total completed answer, and we are finished with that. Another one, if I had, say, how about 4/5 plus 3/5? When I'm adding these 2 together, we add the numerators. 4 plus 3 gives us 7. Down at the bottom, 5 is our denominator, so it stays our denominator. Now, once again, we're not finished. Be prepared to see this. If you run into a case where the numerator is bigger than the denominator, that is always considered an improper fraction, and we always want to get it out of its improper form. Just as we did with reducing those improper fractions earlier, we reduced by division. So we're going to look at this as 7 divided by that 5. So 5, if we were to divide that out, 5 goes into 7 one time. Since 1 times 5 is 5, that's going to give us a remainder of 2. So actually the answer to this problem is 1 2/5. And that's our total answer there at the end. Okay, so you guys are thinking, wait a minute. Not all fractions look like that, and the denominator is not always the same. So we're going to get into that, so hold tight. And yes, for those of you guys who are thinking, okay, but what about mixed fractions? What do I do with those? What if I had 7 and, let's say, 3/8 plus 2 and 1/8? What if I run into a case like this? These are actually totally easy. You guys don't have to really approach it any differently than the ones we've done so far. What happens is, in addition of fractions, mixed numbers like this can actually be broken apart. What I mean by that is you can separate your whole numbers. So looking in this particular example, 7 and 2 are our whole numbers. And then our fractions, 3/8 and 1/8, those can be added separately. So real easy. All you have to do is just take 7 and 2, add those together. We know 7 plus 2 gives us 9. And then now you can add your fractions together. 3/8 plus 1/8 we know is 4/8. And then don't forget to reduce if you can at the end. But that's how you add those together, is you can add your whole numbers separately from your your fractions. So this would reduce then to 9 and 1/2. Okay, so looking at another one just very similar to that. If I had, how about 5 and, I don't know, let's say 3/7 plus 3 and 6/7. Let's take a look at this one. When I'm adding these together, like I said, you can separate your whole numbers. So 5 plus 3 of just our whole numbers, I know is going to give me 8. But we have to hold tight for just a second, because look what's going to happen with our fractions. When I add together 3/7 plus 6/7, you guys are looking at that and going, wait, that's an improper fraction, because 3 plus 6 is 9. So I get 9/7 in this case. This is actually not our completed answer just yet. What has to happen here, because the fraction part of it is an improper fraction, we have to reduce that first. So actually our whole number is not going to end up being 8. That's going to come in just a second. Let's focus on just reducing that 9/7 first. 9 divided by 7. I know 7 goes into 9 only one time, because 1 times 7 is 7, so that gives me a remainder of 2. So looking at just my fraction answer itself is 1 2/7. Well, watch how easy this is. All I have to do is now, when I add those two whole numbers together, once again, 5 plus 3 we know was 8. So 8 is going to come in now, but I simply just have to add it to my fraction answer. So 8 plus 1 2/7 is going to give us just 8 plus 1 is 9. So we just added those together, and then the 2/7. All we ended up doing was added together now the whole numbers at this point. 8 plus 1 is 9, and then 2/7 was my fraction. I'm going to do one more of those because I know those can be kind of tricky, and what happens when I have to reduce the fraction a little bit further. So what I do, my advice to you guys, is just add together the fractions first, and then go back and get the whole numbers, and that will make more sense when we get into the subtraction too. So if, let's say, I have how about this, 8 and how about, I don't know, let's just say 3/5 plus 4 and, I don't know, 4/5. Similar case to what we had on the last problem. So I know 8 plus 4, when you get that, that's going to end up being 12. But we're going to come back and get that 12 at the end. Let's just focus right now on just the fraction part. So looking at just this, 3/5 plus 4/5, if we add that together quickly, adding just the numerators, 3 plus 4 is 7, and our 5 is our denominator. So 7/5 is an improper fraction, so we need to reduce that. Just real quickly, I'm going to do that, without drawing that out. We know 5 goes into 7 one time with a remainder of 2, and then 5 stays my denominator. So my fraction answer by itself is just 1 2/5. But we're not finished yet. I have to go back and get the 8 and the 4. And when I add the 8 and the 4, we know that gives me 12, but I have to add it to my fraction, the 1 2/5. And that simply gives me 13 and then 2/5. And that's it. So not too bad. Okay, hopefully that helps with that. If you guys need to do some more practice problems, go ahead and do so. I'm going to go ahead and take this off the screen now and go ahead and jump in to now what we need to do if we do not have the same denominator. Again, something I briefly mentioned earlier, yes, not all fractions look like that. So sometimes the denominators are not going to be the same. And what do we do if they're not? So if I run into a problem that says something like this, how about 3 fourths plus 1/6? How do I add these two fractions together? This is going to be approached a little bit differently because the denominators are not currently the same. But not too bad. There's just going to be kind of an intermediate step. We go back to what we did at the very, very beginning of class when we were finding equivalent fractions. What we're going to do is we're going to find both equivalent fractions for both 3/4 and 1/6 that have the same denominator. Once they have the same denominator, once this number is the same, then we will be able to add them together. So what we have to do is we have to pick, well, what would be a common denominator or a similar denominator between what we have up here on the board, between 4 and 6. Right now, the numerators don't necessarily matter. Right now, the 3 at the top there and the 1 up at the top, they don't matter. They're not relevant. We're only looking at the denominators down here, the 4 and the 6, and we want to find what they have in common because that's going to help us to then add it at the end. Like I said, once we have that denominator the same, we'll be able to add them together. So let's take a look at this. So let me get some of this stuff off the screen up here. So going back to what we had, it was 3/4 plus 1/6. Sorry, my handwriting is just awful. 3/4 plus 1/6. How do we find a common denominator? What do you mean by that? What I have to find is what's called a least common multiple. A number that they both share. And when I say multiple, easy to get that confused with factors, as a lot of people want to tell me 2, because we just came from reducing fractions. And if we had the fraction, so this is just kind of a little side note over here, if the fraction at the end of our problem was 4/6, you guys are correct with saying they both can be divided by 2. 2 is what's called a factor of these numbers, something that can be divided that they can be divided by. So when we reduce this, yes, 4 divided by 2 is 2, and 6 divided by 2 is 3, so that gives us 2/3. But that's not what I'm looking for. I'm looking for, again, what's called a least common multiple, something that both 4 and 6 share. So when I think about multiples, think about your times tables. I'm going to draw out my multiples of 4 and 6, and then let's compare them. So when I think of multiples, like I said, times tables. So I'm thinking about these numbers times 1, times 2, times 3, times 4, times 5, and let's just go all the way to 6, just so we can compare the two here. So we are going to look at our times tables for both 4 and 6. Let's start with that 4. 4 times 1, we know, is 4. 4 times 2, I know, is 8. 4 times 3 is 12, 4 times 4 is 16, 4 times 5 is 20, 4 times 6 is 24. Got it. Okay, now let's take a look at the 6's. 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18, 6 times 4 I know is 24, times 5 is 30, and times 6 is 36. Great. So, earlier I had mentioned that we have to find numbers that they have in common. Do you guys see any multiples that they have in common? You should. We see that they both share the multiple 12. They also share the multiple of 24. And had we have kept going with these, we actually would have found that they have quite a few more in common. However, I called it the least common multiple. The reason why we want to use the least common multiple, so meaning the smallest of the multiples that they share, so in our case, this 12 right here, the reason why we want to use that is because it's going to be much easier to use a smaller number, so we're not having to reduce more at the end. We very well could use any of the bigger ones, but like I said, all that happens is we're just going to end up having to reduce more at the end of the problem. So we're going to use 12. So we chose 12 as our common denominator. So right now, whoops, I didn't mean to do that. So right now, Our fractions are currently 3/4 and 1/6. So what we're going to do, as I showed you guys earlier, we are going to change both of these fractions to something over what we picked as their least common multiple. So this is going to be their new denominator. Since 12 is a multiple of both 4 and 6, I can change 4 to 12 and I can change 6 to 12. And that goes back to what we did at the very beginning when we found equivalent fractions. Remember, what we did was we changed the bottom number a certain way, so we have to make sure we change the top number the exact same way. So starting first with just the 3/4. I'm going to do that over here on the side just so you guys can see, and it'll show you that it looks exactly like what we did earlier. 3/4, we want to change that bottom number from 4 to 12. So think about what we multiplied 4 by to get to 12. You're right, we multiplied by 3. So therefore we have to do the same thing up at the top, and when we do so, 3 times 3 gives us 9. So there's our new fraction, but only for the 3/4. That's what we're looking at right now. So I'm going to go ahead and write that in down here at the bottom. 3/4, we've now changed that to 9/12. So that's going to be written in down here at the bottom. Okay, so doing the same thing to the next fraction, 1/6. When I change that 6 to 12, I multiplied by something a little bit different. 6 to 12, I multiplied by 2. So I have to do the same thing to its top number. 1 times 2 gives me 2. So now that means this 1/6 I have now changed to 2 over 12. But since they're equivalent fractions, just like we did earlier, how 4/8 was equivalent to 1/2, so 4 out of 8 slices of pizza still meant half of that pizza. Since they're equivalent, they can be used in place of these fractions so that now we can add these together. So now with our fractions being 9/12 and 2/12, you can see when I add these two together, 9 plus 2 we know is 11, and then down at the bottom 12 is our denominator. So the answer to this problem is simply just 11/12. Sorry for everything all over the screen here. Let me go ahead and just erase all of this madness up here, and let's try a different one. Okay, let's say we are adding together, how about 5/8 plus, let's do 3/4 again. Okay, so once again, the denominator is not the same, so we have to change them to where they do have the same denominator. So if I looked at all my multiples of 4 and 8, all the multiples of 4 and 8, let's think. 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12. Let's stop here and let's look at 8. 8 times 1 is 8. Oh, looks like I already found it. Since 8 is a multiple of 8 and 8 is a multiple of 4, therefore, that's my common denominator. So let's go ahead and get this out of the way. We decided that 8 is going to be our common denominator, which means we're going to change both of these fractions to something over 8. Well, as you guys are probably thinking, well, one of them already has the denominator of 8. What that means is I don't have to change the numerator then. So 5/8 can just stay 5/8 since it has the denominator I want it to be. Where over here on the side, 3/4, it does change. Since we changed that 4 to 8, remember we have to change the top number the exact same way. So 4 to 8, we multiplied by 2. And so what we need to do is make sure we do the same thing to the top. 3 times 2 gives me 6. So in place of 3/4, I'm going to use 6/8. And now I can go ahead and add these two together. 6 plus 5 gives me 11. 8 is my denominator. Remember, this is now an improper fraction, so don't forget to reduce it. 8 goes into 11. I'm thinking of, remember, reducing. I'm just doing this real quickly. 8 goes into 11 one time. Since 1 times 8 is 8, I subtract, and that gives me a remainder of 3. So my answer is 1 3/8. So I hope that helps with the common denominators. You know, if you need to stop and practice a few more, go ahead and do so. In the next video, we'll jump into subtraction.